Good evening, participants. We are going to start with the session for the day. And as you all know, that today we'll be starting with one important library in data science that we call NumPy. So I'll be again doing several practical exercises on Google Colab platform here, and we'll be learning how different libraries, as today's focus is NumPy, may help you to deal with your numerical datasets. First of all, a little bit detail about NumPy library that you may need to know as a beginner. NumPy, as the name indicates, we write it something like this, NumPy library. So this means numerical Python basically. This NumPy indicates numerical Python. So whenever we have to do some kind of numerical computations or calculations we have to deploy on datasets, then NumPy library is preferably used. Although in core data science operations, you cannot only rely on NumPy library. You need to combine it with few other libraries such as Pandas, scikit-learn, or maybe Matplotlib and sklearn, etc. So that we are going to learn in coming days. But yes, today's focus is the very first library for data science that we call NumPy library. So as I told you in the previous sessions also, that in Python there are thousands of different libraries, and in each library there are a set of functions that we can call, and we can use them for different requirements while setting up our numerical calculations or handling variety of datasets. This NumPy library also contains thousands or more than that different functions inside that as per requirement we can call for handling our dataset. So in today's session, I'll be demonstrating you few basic details with this NumPy library. First, I'll be dealing with self-created arrays or matrices, like the basic format of data I'll be creating here, and we'll be doing some operations on them. And after that, I'll be using some CSV files. I hope all of you might have received the CSV files that I have shared in WhatsApp group by now. You can keep those files ready on your system, on your laptop or desktop. So we'll be just taking them to this Google Colab platform, and I'll be showing you few operations on those CSV files also. So let us start with the very first step here, that is to import NumPy library. The very first task is to import NumPy library. We have just started with the introduction of NumPy library. I was explaining why it is used and what are the benefits of this library. So we have discussed that NumPy you can utilize for various numerical computations because this is a numerical Python library. This uses various inbuilt functions to do numerical transformations on data. It can deal with various lab values, various types of signals obtained from healthcare data, patient vitals, etc. Everything it can process easily because it has ability to deal with numerical values directly. And this library contains thousands of different functions that can be utilized for various mathematical calculations on data. And now we are learning how we can first import this library. So it is important to understand that NumPy is also a essential library on data science grounds, and this is by default available on Google Colab. Yesterday also I have told you this thing while we were installing Gradio app over there. I told you there that some libraries are by default available on platform and some we need to install. So I have shown you one installation code also yesterday. That was sign of exclamation pip install and then name of the library. And after that, I have also shown you an import technique where you just have to write the import syntax, then name of the library, and then as any nickname that you want to give to that library. So there were two different lines. One line was for installation, other line was to import already installed library. So as I'm telling you here that NumPy is by default available on your Google Colab platform. So you need not to install it. You can directly import this library. And in order to import it, we will write NumPy as NP directly. So I can load it with the nickname NP, and the same name I'll use throughout. So I'll just run this thing and it will soon get our NumPy file ready on our Google Colab sheet. I'll also create Google Code Share window side by side. I have placed this Code Share link in your chat box window. You can open it from there. After importing your NumPy library, now we will start with NumPy Array Basics. The very first thing we are going to start is NumPy Array Basics. In the previous sessions, we have talked about list creation in Python platform. And I have told you there that list is stored in, okay, I can ask that from you. Which brackets are used to store list? Which type of brackets we can use to store list? Yes, very right. We can use square brackets to save list content. And I have shown you that in list case, that lists can contain variety of data types in single variable sequence. Like we could create mixed data type in list. We can combine floats, int, string, etc. into single list element. So in difference to that, NumPy arrays are some kind of matrices of your numerical values. They can be in the form of vectors, they can be in the form of matrices. Vectors are generally your single row or single column type elements. They are termed as vectors mathematically. And when we have multiple rows, multiple columns, that becomes your matrix. So these are some mathematical terminologies that I suppose all of you may be aware of. So in case of arrays, you generally store numerical data only. Although when we deal with arrays, there will be square brackets available. You will see square brackets, but that doesn't mean that it is a list, because I'll be storing those values with NumPy library. And when np.array is written there, that means it is a purely numerical data only. There will be no string information, etc. Generally, NumPy arrays are purely numerical data types. So they will be containing either float or int, but no string. So whenever we are using NumPy library, we'll be dealing with numerical data only. Tomorrow, I'll be showing you pandas also. Pandas is one more important library that is most popularly used in data science. And at that time, I'll be using NumPy and pandas all together to see how easily we can handle data in that case, because pandas give you ability to deal with alphanumeric data set. So whether it is in the form of strings or numbers, both type of data pandas can handle. But today we'll be talking only about numerical data. So we will see how NumPy can handle numerical data. So first array I'm creating here, I'm writing here creating basic arrays. And for example, one array of patient temperatures I'm creating. So the technique to create array here is, we need to first use np dot. np dot means we are just calling NumPy library. And with dot operation, we can further call any function, any built-in function available in NumPy. So this array is itself a function. You can see I'm calling it with round brackets. And when something is called with round brackets, that represents a built-in function. So from NumPy, I'm calling a built-in function named array. And inside this, I'll be storing my values. So 98.4, 99.1, 101.2, and 102.4 or 5 maybe. Maybe these are my temperature values. So you can observe that inner elements, I'm writing more like a list with square brackets. But now this list is associated to NumPy array. So we will not call it a list, rather we will call it an array. And the difference I have already told you that this will represent pure numerical data. So NumPy gives you more freedom to have numerical calculations in comparison to list. So I'll just run this and you can observe this kind of vector sequence or a simplified array we have created, and it is stored in our memory now. I have shared this code in the code share window also. And in the same pattern, now you can create any number of arrays. You can just do a little bit practice, like we are creating array for heart rate. So you can save those values directly inside your NP array function, and then you can check those heart rates. I'm just using very small number of values for the demonstration only. So currently these two are technically named as one-dimensional arrays because they are presenting just a direct sequence of variables. So they have only single dimension, like they have only rows available. When your data storage have both rows and columns, it becomes a multi-dimensional array, or generally you can have 2D array when you have basic like 2 rows 2 columns simple pattern you are using. So 2D array, and then you can have multiple dimensional array also when your number of columns and rows increases in your data further. Starting with the very basic one, currently we are creating one-dimensional arrays only. Let me know if it is clear up to this. Okay, great. I'll show you what dimension means. If it is not clear, let me show you it in a comparative way. That will bring more clarity to you. For example, I'll create one more data, like maybe BP information I'm storing. And this time for BP, I need two types of entries, systolic and diastolic. So I'm saving it something like this. You can observe here. 150,95. Observe this. This is first set of values for systolic and diastolic, and this one is second set of values, systolic and diastolic we are creating. So I'm running this and this BP value. Now you can observe difference between these two, the HR array and BP array. Can you identify the difference between these two? They have different dimensions. One of these is going with single dimension. They have only, yes, you can also consider it a list somehow, but generally we call them array only when we are dealing with NumPy. That difference I have told you right in the beginning. They are basically in multiple dimensions. We are trying to store them based on the combination of values. And we can even check these kind of things by using specific functions. I'll show you how we can do that. For instance, NumPy array attributes we'll try to check here. Till now, these three different arrays I have created. Now I'll check their essential attributes. So I'm writing here, the first array was temperature array, and I'll be checking its shape, for example. Let us check its shape. So if I run this, you can see 4 comma, after comma, there is nothing right now. So this shape generally gives you row comma columns basically. So it is giving only rows. After comma, there is no value, means there are no specific columns. Just a single column with number of rows is present. When there is a single column, then the column information is not given with the shape function. So it will generally bring you details. Let me just open up the whiteboard also side by side. So you can observe that if you are storing some values like this, maybe 201, 89, 90, 77. So this contains only single column and there are 4 rows. So if I try to check shape of this by taking help from our inbuilt functions available in Python, it will be represented as 4 comma nothing. This is the general way of presenting shape of any array in Python. In case, if I take the second example, maybe if I have stored something like this, 20, 41, 22, 55. Now this is a matrix of 2 cross 2, you can say. And if I try to check its shape, it will present that shape as 2 comma 2. This is row, this is column. So number of rows and number of columns it will present. When this is row and column, when column is equal to 1, in that case, second value in Python is not presented because that is considered as by default, that if rows exist, then definitely single column is there. So that is considered by default in Python. So they will not write 1 in this case. Rather, they will keep it empty because that is basic consideration. However, if it increases further, that dimension will be clearly provided, that these are the number of rows and columns. So if I try to check this shape method on BP, on this one, if I try to check, for example, I'll write here print BP dot shape. You can observe 2 comma 2. So this is, we can also say that this is a two-dimensional matrix right now because it is having rows and columns separately presented and there are 2 columns available. So two-dimensional it becomes in that time, in that way. There are also specific functions available to even check directly dimensions. There is ndim function, this kind of method available, ndim method. So if I try to check dimension, it says 2. You can see. So it means this is a 2D matrix. Similarly, if I try to check hr.ndim, so this will present it as a single dimension. So we will write 1D matrix for this. If you remember, HR, I have created something like this. So this was your one-dimensional matrix. So in this way, we can even verify what kind of dimension we have with our data set. I'm sharing this code in your code share window also. Try this and let me know if this is clear. Further, I'll be creating bigger data sets also, but first we are learning the basic ones. Try this and let me know when you are clear up to this. Okay, observe here carefully. I have created multiple arrays here. First, you need to observe difference between them. This array, this is simply list of elements. You can also consider it. And this currently represents a data that is something equivalent to this sequence. Means single column and multiple rows. So one column only and four rows. That is presented in our this temperature array. Four entries that are stored in different rows, but there is a single column, and column name we can say that temperature readings we are storing in a single column. Similarly, HR, we again have four entries for heart rate, and they are stored row after row. So single column, multiple rows again. Now this one, this contains two rows, two columns. You can observe how I have stored it. So this is appearing like this, two rows and two columns. So it is a data that appears something like this. We can see here something like this, 2x2 matrix. So if we check shape of these data sets, the upper one will appear 4 and bottom one will be 2x2. Row and column elements will be presented like this. This is what we discussed recently. And based on this, we are checking dimensions of our data. You can observe for the temperature dimension, it will say 4 comma nothing, because I told you recently that if there is a single column, that is not presented in shape because that is considered default value. So they do not write anything after comma. But if there are more than one columns, so that will be added into the dimension of your shape function. So we are writing here 2 comma 2. So that shows that this BP has 2x2 matrix. Then further, we have number of dimensions represented for BP and HR. Like in mathematics, generally we say one-dimensional matrix, two-dimensional matrix. That kind of test we are conducting. So this one appears like a 2D matrix. And any of these previous ones we can check, they will appear as one-dimensional matrix. So this is number of dimensions. N dim, we are writing number of dimensions in your data. We are checking with this. Let me know if this is clear now. You cannot say that dimension is just rows. Dimension is the combination of rows and columns. Because if you have so many, for temperature case, I just said, I have also shown that in whiteboard here also. The combination is row comma column. For temperature, your number of rows are 4. Number of columns are 1. And I told you recently that column number is not written in shape if it is 1, because this is considered default. That is why shape we are getting 4 comma nothing. 4 rows and columns is not presented here because that is 1 right now. That is the default method to present shape outcome. I hope this is clear. Okay, so moving forward with few more operations, I'll write here indexing and slicing operations on array. Just few basic only I'll do, not very extended ones, just to give you an idea about that slicing and indexing also works on arrays. So for this, for example, the HR array I'll consider again. You can use it as it is, but for the recent reference, I'll take it again below so that you can visualize the data side by side. So HR array, for example, we have created here. And then I'm trying to print HR, and maybe I need I'll give you a simple task here. Indexing we are doing here. Indexing technique you have to use. And on arrays also, both positive and negative indexing will work. So I'll increase, for example, number of values here. Maybe I just increased these number of values. Now I'll ask you based on the indexing operations. I have shared this in your CodeShare window also. Maybe I need to extract this value. What index I should use for this? Great. So if I use HR2, I can extract 20. That goes fine. And there are two values, 120. I'll just change this one so that we can verify well. So if I need this one, for example, by using negative indexing, I need 123 and I need to use negative indexing. Yes, that looks fine. So I'll just insert this one and -4. So 123 I could retrieve. In the similar manner, we can use slicing operation as well. Here I'm writing positive indexing, and here I'm writing negative indexing, and then I'll try slicing also. So for example, I want to slice this component with these three values. You can use positive slicing is for ease. Just help me get these three values by using slicing. What is the intermediate symbol? You need to remember that also. Should I write 2,5 or there is other symbol? Yes. So I need to write 2:5. And if I do this, I can extract those three elements from our dataset. So we need to be careful about the syntax that we can use in Python. So I'm writing here slicing. So just to get an idea that in the similar pattern as we have used in list, we can do indexing and slicing operation in arrays as well. And there are few further possibilities as well. As I told you that NumPy arrays give you wider possibility to apply mathematical tools. I'm writing here, for example, from a temperature sequence, I want to identify abnormal temperatures, or maybe when a person has a fever, that thing I want to check. So I'll write here filter fever values, or filter temperature that indicates fever. You can write it that way also. So maybe I'll write here a NumPy array. Inside this, I'll store some random values of temperatures. So for instance, these are few temperature readings we have taken. And I'm applying a condition for fever. Temperature greater than 100. You will see the interesting outcome over here. See, it could extract those values in which temperature was greater than 100. And how I applied this method, observe that. I called this specific variable that I have used, and then within square bracket, I applied a mathematical formula that will every time apply a condition on each one of these values, and it will check if they are greater than or less than the given threshold. And wherever it gets a value true, these things work as true expression. So that will be considered into main variable. and only those two values will be presented in the output. So this is how we can apply direct filters on these arrays. I'm sharing this. You can change this filter and try extracting different values, and then let me know if it is clear. Currently, we are learning just some basic filters only. Later on, maybe when we do future exercises in upcoming parts of this course series, there will be learning high-end filters also, like for specific uh, operations on data, how you can create some customized filters that include multiple rows and columns, etc. Let me know when we are all good up to this. Okay, great. Thanks for the update. In the similar manner, we can apply variety of different mathematical operations on these values. For instance, I'm writing a simple sequence here, like just some random values only I'm inserting. Maybe these three values are there. And I can do a direct operation, reduced BP. Maybe after certain treatment, you are expecting that BP will be reduced by 0.9 for the patients. Just a very random hypothesis I'm taking. So we can see the updated BP after applying the treatment in that case. So you can see the updated value after multiplied with 0.9. So direct mathematical operations are possible to apply on arrays. I have just given a simple multiplication here. Later on, you can try other operations as well. One more example I'll add in sequence, that is to apply some aggregate functions on NumPy arrays. And for this, I'm updating here first glucose, and I'll write here NumPy array. Inside this, some values I'll be updating one by one. Just some random entries I'm making for maybe patient vitals that we have received. And now on this, for instance, we want to calculate mean values. So the method is direct. Glucose mean we can apply. Similarly, if you need max value available in your data, you can apply that also, writing glucose dot max. For everything, direct functions we can use. And maybe standard deviation you want to calculate. So that also we can do right here. For that also, direct function is available. I'll write glucose dot std. So just this variable in which my data is stored, I'm calling that, and I'm applying direct function to this. Just a few of them I have applied. Otherwise, there are hundreds of such functions that, as per your requirement, you can use further. So I'm just running this, and you can see it can make all calculations quickly for us, and we can see the outcomes. Like the mean value for all these variations it has calculated, the maximum value 188 found, and then it has also calculated standard deviation for all your entries. In the similar manner, there are formulas for min values for many other mathematical distributions as well. You can apply directly. Try this and let me know if it is clear. So in yesterday's classes, we have designed some BMI calculators also. Why there is a dot in this? This dot is 0.9. I'm writing 0.9 here in output. Okay, because I'm writing here 0.9, na? So this is taking it as decimal value. But because there is no specific decimal digit after it, so it is not presenting that zero, but it is just considering that if there is any decimal value that can be printed side by side. For example, if I put it 160.3, then that decimal value further will be added automatically. It is just showing that because multiplication is done with a floating point number, so there should be something after decimal. But if that is zero, it is not showing that, just dot it is showing. Let me know if this is clear. Comma will not show. Which comma you need? These commas are you talking about? Yes, these commas after applying this operation will not be presented. It will be presented as, or you can check it in one more way, like reduced BP. If I apply directly, you can see here I'm using it with print command. So in print, it will just print the values directly. And if I call the variable as it is, then it will present it as an array. So in array, the comma will be visible. When I'm using it with print statements, then it is printing the values only. Okay, so we are moving further. I was talking about that yesterday we have done some basic BMI calculations, but at that time we were working on single entries, like for one patient, weight and height we were putting, and then we were getting the calculation. But for instance, if you have a complete sheet containing weights and heights of the patients, in that case, how you will deal with it? So first, I'll create here arrays of weights and heights, and I'll apply formula on that directly so that it can calculate BMI for each one of them automatically. And then later on, further, I'll be using it directly on a CSV file also. Then we will see that how on manual arrays and how on CSV files everywhere this NumPy will be able to help you. For the basic operation, I'm running it right here. Furthermore, on CSV file, we'll be using the sheets that I have already shared in your WhatsApp group. So let us create here the basic operation. I'm writing maybe heights in centimeters and weights in maybe kg. So that I'm mentioning initially that this will be my presentation in particular data set. So first case, NumPy array I'm creating here. And inside this, some random set of values we can insert for now, just for the calculation purpose. So these are some tentative values I have inserted for heights. And in the similar pattern, I'll be inserting few values for the weight in kg as well. So maybe 70, 60, 80, then maybe 50 or 75, maybe 45, maybe 89 and 65. So make sure you have equal number of entries in both sides, because then only you'll be able to do calculation with respect to each other. If your count is different in both arrays, then you will get an error, because when you apply those formulas further, they will not be applicable on empty side of your array. So make sure you have equal number of entries in both sides. So in my case, I currently have 336 and 8 entries. So in both cases, I need to have 8 entries so that the calculation is feasible. Then we are calculating BMI values, and we can directly apply the similar type of formula that we have used last time. Like I can use weights in kg here divided by heights in centimeters divided by 100 and raised to the power uh, 2. So I'm just applying formula here based on all the entries that we have created initially. Based on that, the BMI values we are calculating. And further, I can enter here patient values, patient heights. So that will be taken from height CM. We are now just trying to print each one of them, all of the values, so that we can see how the calculations have been done by the system. Then weights I'm writing. Furthermore, the newly calculated BMI values I'll be writing. So here the BMI values I'm updating. The print sequence for that. You already know how to add this into GUI interfaces. So there also you can update later on these kind of details. But currently we are using it for the basic simplified versions here. So I'll run this and you can see in the similar pattern, it created one more array which contains all the calculated BMIs. I'm using the calculated values as it is in a new array right now. And on this, you are free to do many other calculations also now. I have shared this on CodeShare window. So for instance, on these calculations, whatever we are getting from here, maybe we need more mathematical values. Like for instance, I want to calculate NP mean for maybe BMI values. So it will calculate us mean in that case. We can put it inside your print sequence also so that a cleaner representation is given. So exact value for BMI mean it is presenting. Similarly, I'll put it inside another print and here I'll write NP dot max value maybe for weights in kg I want to know. So I can see this is the maximum weight level available in my data. So it is possible to do calculations between your different arrays and on single dimension of the array also. You can update your values quickly. Try this and let me know when you are done. So the basic array operation will close here and we'll start with how to use CSV files directly in NumPy. So first let me know when you are done up to this. You can practice it with any number of data variables later on, and you can check how you can apply different formulas in between. I hope others are also able to do it. So I'm moving to the next part from here, that is to load directly CSV files into NumPy. It is important to mention here that your NumPy doesn't directly deal with CSV versions of data, but we can load CSV file data as an array into your NumPy. Tomorrow we'll be working on pandas, and there you will see that how exact CSV file we can directly put on the Python platform. So pandas is specifically available for dealing with directly CSV files. But currently on NumPy, we will be using CSV files as raw data, but that data will be automatically extracted as array by NumPy because NumPy is dedicated for the array version of data. So even if we supply CSV to it, we can convert that into array so that it fits into NumPy operations. So what I'll write here, first of all, load CSV into NumPy. Maybe this is the first task we are doing. And for this, I have these three different datas that I have shared with each one of you. I suppose all of you have obtained this data from WhatsApp group. Let me know quickly if you have 3 data files received on the WhatsApp group. Accordingly, I'll tell you. Okay, great. If you have loaded on Colab also, great. Otherwise, those who have not loaded, I'll tell you how you can do that. So we will just come back to the sheet here. And first of all, I'll tell you how you get those data files on your Colab. If anyone doesn't know, observe this carefully on your screen. Yesterday, I have shown you the files section. It is available right here. So you just go to file section, and currently it is empty. Only sample data folder is there, nothing else. So I'll get those CSV files for the runtime over here. Observe my statement carefully. I'm saying that I'll get those CSV files for the runtime onto this section. When we say runtime, it means as long as this coding sheet is active here, means I'm not closing this coding sheet. For that time, that data will be also active on the sheet. Once I close it, that data will be also lost. After that, it will not consume any memory. So next time when I have to use these operations again, I just have to load that data again for runtime, and I can do all the operations similarly. The code will stay as it is, just the data will be lost, so that no memory is consumed for storing that data in the meantime. So first thing you need to learn is how you get your data set into this section, because from here we can access that directly into our cells. Because currently this Google Colab is hosted on Google servers. It is not using your system's memory and CPU, etc. It is using everything from Google servers right now. So it doesn't have direct access to your PC memory. You need either specific functions for that, specific code for that, or there is a simpler technique to upload all your data files to this section. So observe how we can do that. There are two ways. One is drag and drop method, other is upload method. So I'll show you both one by one. I'm just reducing the screen size, and I'll drag any of these files. For example, this diabetes raw data file I'm dragging, and I'll just put it here in the empty space below sample data. And you will always get a warning when you upload this data, because this is that it states that your data is coming for the runtime only, so that you stay aware that this will be available for runtime only. And depending upon your data file size, it will be instantly available here. If the data file is big, it will take some time. Otherwise, for the small data set that I have shared, it will be quickly available here. So one option is direct drag and drop. If you are not able to do drag and drop, there is second way. Observe, we have a upload sign here. Below files option, we have here a upload sign. If you click on this, it will take you to any folder available on your system. So you can click on any number of datasets now. Like I want these two. The other two datasets that I have shared with you, I can just click on them, and I'll just click on open. So both of them will be soon loaded into this section. Now you can see all 3 data files are ready here. Try this and let me know when you all have these data files ready in this section. Others also, please let me know, because if you have these data files here, then only you will be able to do next operations. Without having data files here, you will get error. Okay, great. So these data files are ready, and one by one I'll access them. First, I'll start with this diabetes raw data set. Let us see what we have in this Excel file. I can open it up right here first. This is a file that I have shared with you. This contains some information available on diabetes cases. This is just a publicly available dataset, not taken from any hospital. This dataset is publicly available online, so anyone can use it for basic learning process. So there is one outcome window or outcome variable by the end, which indicates whether the person is suffering from diabetes or not. So 0 here indicates if the person is healthy. 1 indicates if person is suffering from diabetes. Similarly, there are remaining essential features obtained from patient parameters or vitals, etc., from the patient. So they are listed in the starting sequence. So based on this, you can do variety of analysis on this data. We are currently not doing a very in-depth analysis, but we will just learn how NumPy can help us to deal with this data. Just the basic operations I'll try to do on this. However, in general, if we consider what we have learned in the previous day sessions, can others also please confirm if my voice is lagging? Uh, in that case, I'll reconnect. Can you quickly confirm in the chat box if you are able to hear me right? Okay, thank you very much for the confirmation. Ms. Richa, in that case, maybe you may have some trouble with your internet. Kindly recheck, and maybe you can rejoin also if it doesn't work. You can take just a single moment to close and rejoin again. So maybe that will help. Okay, coming back to the parameters here. So I'll just first load those parameters directly on my this Google Colab file. And for this, I'll be writing here a simple code. NumPy library I already have. I'll be loading this CSV file into a data variable right now. Just for the ease of access, I'll store it in a data variable. And then np.gen from text variable function I'll use. What it says, generate from text means it will consider your CSV files as a textual data, and from there it will generate a array format further. So by default it will do that. So in order to apply this function, it will first require address of your data file. So one option is that you can manually type name of your data file .csv, then also it will work. That is one option. Other option generally that you can use in majority of cases just to save time, instead of typing manually, you can get your file address directly from your files section. Observe how you can do that. We'll go to the file option here. I need this data file right now. So I'll click on these 3 dots and I'll just copy its path. Everyone observe carefully. What we will do, I'll hover my cursor on diabetes row and I'll just click on these 3 dots and I'll copy this path. There is one more way to do this. You can simply right click on this file and then also this copy path option will arrive. So once you copy this path, you can paste it right here within inverted commas. So this will establish direct connection with your data file. Then I'll pass few more parameters. I'll state here delimiter is equal to comma separated file because we are using a CSV file right now. So I need to specify that this is a comma separated file from where I need to create an array. And further, one more thing, I'll write here skip header equal to 1. Why I'm doing this? If you remember, I recently told you that with NumPy array, we can deal with numerical informations. But when we have this raw data, this diabetes raw data I've shown you, the first row contains alphabetical information, that is names of your columns. So this will not be accurately processed by your NumPy repository directly. So we are just skipping this first column so that only the numerical entries that are available further, they will be taken into the data file. Otherwise, these entries, if I try to take them as it is, they will be stored as nan values, means missing values by the system, and they will create disturbance in our further analysis because they will show error time and again. Since NumPy is limited to work on numbers only. That is why I'm adding here one more parameter, that is to skip header, means the first line that where the header is available, that should be skipped from data. After this, I can check maybe first 5 rows of my data, print first 5 rows of data. So I'll just run this and we can visualize. You can see in the form of array now, I can see this data. This by default comes in the form of e raised to the power. That is the by default pattern of arrays in NumPy. But this is actually the original data only that we have here. This information only it is containing right now. When we apply any mathematical operation, it will contain the original information as it is that we have used in our CSV data file. So I have shared this link, this code in your chat, in your code share window. Just try it from there and let me know if you are able to get your data something like this on your screen. And if the point is clear that how we load a CSV file using NumPy directly. I hope others are also able to do it. I can also check shape of this particular data file now, just to know how many rows and columns are there. In the first method, you have to type name of the CSV file. Are you talking about this one? Please let me know which portion you are looking forward to. I have used CSV file here only, nowhere else I have used without copying the path. Yes, yes, in that case, definitely .csv you need to provide because that is your file type that has to be written essentially. Otherwise, you can use copy path. If you are using it directly, then this thing you have to type as it is. Because this content is its core repository. So even without writing this, you will still be able to access diabetes.raw because that is a core library, the core repository that is automatically considered by the system. But otherwise, the real path is that appears with this content section because this is its content section basically, from where it contains your data file. Okay, so data shape I have checked recently. You can see here it shows that, okay, can anyone tell me shape method? I have told you several times now. Can you tell me quickly, what does this shape outcome indicates? What are these values representing? We just discussed it recently. So I suppose you all remember what we have discussed. Okay, I can see the outcomes here. So, yes, this is a 2D array. That is fine. There are 9 columns, of course, and there are 768 rows. That is also fine. So, in the first set, this represent your number of rows, and this one represent your number of columns. So, based on this, we know that how much data we have in that CSV file. Now, further, I'll add few options here. Like I'll add one important detail, check presence of missing values. For example, we will write check presence of missing values. The data file that I have shared with you, although this diabetes data file, when we access it from the online publicly available source, this comes in a clean format. But just for your understanding, I have manually removed some data points from this file. You can see I have some empty sections in this. Randomly from few positions, I have removed its values just to create a discrepancy in this data set so that we can understand how the cleaning process goes on. So in practical, sometime when you create these type of data sheets, there may be missing entries practically. So in order to deal with them, what you can do, how NumPy can help you with that. Let us see that. Although when we do real data science practices in upcoming in level 2 course, there I'll show you the statistical methods also to deal with missing values in data, because there we'll be doing real case studies with real-time healthcare data set. I'll take variety of data files and I'll show you how we do feature engineering, how we deal with missing values, the practical way or the research preferred way we'll be discussing over there. But today, just some basic techniques considering the fundamental level that we are covering in this course. So let us see how we can first check if there are any missing values in this data or not. So for that, we have one simple operation, is nan operation, available in our data, in our Python repository. Observe what I'm writing. I'm using a isNaN function from NumPy. Note that nan value in Python indicates missing value. Wherever a value is missing, it is considered as nan values. That is not available means. So nan value representation is used for any kind of missing data in Python. And isNaN function will automatically help you to check if the entry in your data, it will check every row and every column one by one, and wherever it finds missing values, it will mark it as true and false manually. Means this function at the back end of your datasheet, it will mark if it finds missing value anywhere, it will turn it true. Everywhere else, it will show false. So for instance, if I use it in its original format like this, if I run it like this, you can see something like this, because majority of values are present, so it shows false. But somewhere in between, wherever I have skipped those data points, there it will be showing true in that case, because this Python platform has a limit on how many rows and columns in one go it can show. That is why it is not showing entire data set. It is just skipping some intermediate rows and columns automatically due to its intermediate limit. But still, we can just understand that by default, it gives you true and false. So I can make it better. I'll write here dot any. I'll combine one more function with it so that I can at least know whether there are missing values or not. And if I deploy it like this, it will say if true, if the answer is true, means dataset contains missing values. Because what it is doing, on these trues and false, it is checking if any by automatically. So if it finds true somewhere, it will say that, okay, missing value check is true. So if I run this now, you can see NP true we are getting as an outcome. Means our dataset contains missing values that I have shown you using datasheet specifically. So in this way, you can quickly find if there are any missing values in our data that I have highlighted here. Currently, we are not noticing any specific presence, like a specific row and column entry we are not marking here, just a altogether analysis we are doing that, okay, this file contains missing values. Now, one more thing I'll do here is I'll use count total number of missing values in my data. For instance, you just need to know that how many values may be missing in this particular file. That also we can check precisely here. I'll write isnan data dot sum. Observe, earlier I did any. So at that time it was just applying. That is just a representation. Don't worry about this. That is just a way to represent. By default, it will come like this. This is just a representation it gives as a NumPy outcome. So here I'm applying one of these is a Boolean operator. This any will do the Boolean function behind, like checking if any is present. And this is a normal sum function. So wherever it finds those true, it will just sum up that count. And if I run this, it says that there are 7 missing values. This int64 is the by default way of arrays to present data. So you might have seen that when we have created these arrays earlier also, in these conditions, these arrays. So we had different types of array options here. We had totally numerical arrays, we had floating point arrays also. So when we deploy some calculations on these arrays, like we are doing it all recently, so it will identify whether it is a complete integer or it is a float. So in NumPy arrays, generally int64 code is used to represent integer values. There are inbuilt codes used to represent different types of values. You need not to worry about this anyhow. You just need to worry about what value you are getting. That you are getting 7 missing values in your data. Try this and let me know if you are able to identify missing values in your data with this. Now I'll take it one step further. Let us check missing values per column now. Currently, this is showing total number of missing values in the entire sheet. We have 7 missing values. Maybe you want to be more precise now, that in which column I have missing value. For example, you need to know that, because generally to treat missing values, you do column wise operation. Majority of time while handling or doing analysis on data, we do column wise operations. So it is better to know in which column you have missing value, so that maybe if those columns are not essential right now, maybe your priority operations are on columns other than that. So you can keep on working and later on you can handle the missing data whenever it is possible for you. So the column based sequence generally we can get for the missing entry. So what I'll do here is I'll create one more variable, that is missing per column, just a random variable I'm creating. And inside this, I'll pass np.isnan. Inside this, I'll pass my data file and sum. Inside this time, I'll pass x is 0. Observe this, I'm passing x is 0. So this will automatically ensure that the values are checked across all the columns. Here, I was not applying any kind of x's. In this case, I'm applying x's so that it will ensure that it does all the column wise checking and sum according to column presence. X is 1 and X is 0 separately are representing your column axis and row axis. Currently, we are working on the column axis. So I'm writing here X is 0 for that. So I'll write here print, and inside this, I'll specify missing values per column we are presenting, and that I'm writing with, I'm just taking it with a precise summary here. So that is why I'm adding with the print statement so that we can see which columns have those missing values. So you can see in your second column, you have 1 missing value, in your fifth column, 2 missing values, and so on it is presenting. So you can accordingly see the specific columns, whether they are essentially to be treated right now, or maybe if you are working on these columns right now, they already have zero missing values. So you can keep on working, and later on you can deal with other missing values that are creating trouble in your analysis further. So I'm sharing this code also in your code share window. You can try this. I hope we are all good up to this. So I'll apply one more operation here. That is to remove rows with any missing value. Just a simple operation I'm applying. Today, the operation that I'm doing in this, we are just removing those rows straight away wherever we have missing values. But this is not always the practical case when we are dealing in data science operations. The actual statistical significance we'll be discussing when we do case studies in future. In today's session, I'm taking just a basic reference only, that wherever you find missing value, we are just removing those rows from our data so that we can continue with the calculation further. In tomorrow's session, when we'll be using pandas, I'll also show you one more way to deal with missing values. That is by filling those missing values. Like instead of removing entire row that contain missing value, we can also fill those values by using some statistical means. So that we will be discussing tomorrow. Today, let us understand one basic operation, that how we can clean our data by just removing all those rows. Axis 1 here will be representing your row axis. That generally goes by default also majority of time. So specifically for the column, I have mentioned here axis 0 because we are working on 2D data. So that is why two axes are there. It is automatically going to represent it two ways. So I'm creating here clean data, for example, clean data further after removing missing values. And to remove them, what I'll do here is observe, I'm taking this section. This, not this, I can take the any section actually. This one I'll take because this was a better filter to check presence of missing values. So np.isnan data.any. Now inside this, I'll apply axis 1 because I told you that I'll remove those rows. And I told you recently that rows will be operated with axis 1. So now I'm operating over axis 1. So any row that contains missing value, that I'm trying to identify first. And before this, I'm using here a negation operator. Observe, this sign will be available on your keyboard also. I'm using a simple negation operator, this one. So what this will do, wherever you are finding missing values, row wise, those rows will be skipped automatically. So we call this a negation operator, or an operator that will help you to select something specific and it will help you to remove that specific thing. So we are selecting those specific rows that we don't need. That is means wherever missing values are present, and we are just neglecting them from our data, and the remaining data only will be taken. So with this operation, it will happen actually. This negation variable will do this operation to skip those rows wherever missing data is available. If I don't apply this, in that case, it will take all those rows wherever missing data is present and it will skip everything else. Because this filter actually is going to identify those rows only that contain missing values. So if I have to remove them, I need to apply a negation operator in front of it. So if I do this, and after that, I'll check my clean data shape. After updating this, I'm checking clean data shape. You can see this value is reduced now. verify it with your previous version of data, you can see that it is reduced by 7 because we had 7 rows in which data was missing. However, this 7 doesn't link to this 7 because that was count, but maybe these missing entries were all in different rows. So that is why it is indicating, because earlier we had 768, I think, count. So 7 values are reduced now and 761 is left. Try this and let me know if you are able to understand the difference between previous data and how we got it after cleaning these rows. Let me know when you are done up to this. I cannot see any responses, so I'll just assume that everything is going fine on the other side. Okay, great. Thanks for the update. So the next entry I'm making here is, let us learn one more thing. We are slicing columns from the CSV file now, means the CSV file that we are using in the form of array. Let us check if we can slice columns directly from there also. So we are just extracting specific variables from our data file now. So if I try to check my original data file, maybe, let us compare it quickly. Because the one problem with NumPy is that it doesn't contain names of the columns. Tomorrow, when we do it with pandas, you will see the clear difference, that how that makes it easier to handle CSV files. But still, few operations are good with NumPy. When they work in collaboration, then it becomes more useful for the data science operations. But still, we are just learning independent library capabilities right now. So currently in my data array, I don't have this header column. I just have these data entries. So I need to mark first which columns I may need for analysis. So I'll be picking just few columns only. Like maybe I'll choose maybe glucose column, or maybe blood pressure column, and I'll choose BMI column, and one of these I'll choose is outcome column. For example, I'll do operation one by one on these. So as we know that in Python, your indexing starts from 0. So this will be 0th index, this will be first. So if I have to get glucose, index value will be 1 in that case. So what I'll do here is, I'll write one by one. First of all, glucose variable I'm extracting. And how we can do that? Observe here a technique. When I'm applying it on a CSV data or a array data that contains multiple rows and multiple columns. Till now, the indexing that we have applied, that was containing a single vector sequence, means single element only. Observe what we have done earlier with the indexing, if you remember. They were having a simple sequence like 2, 4, 5, 6, 7, 8. This type of sequence we were having. So at that time, we were marking it specifically with direct index values. We were taking either positive index 0, 1, 2, 3, 4, 5, or negative index like this. Because they were direct entries only, so we were not looking forward for a two-way addressing. We were not worried about column or row indexing at that time. But now I have data that contains multiple rows and columns. So the indexing will be updated accordingly. Because now if the data is like a matrix, something like this we have. 2, 3, 4, 7, and maybe 8, 0, 1, 2, 6, 7, 8, 9, 3, 4, 2, 1. Maybe this is your matrix right now. So this time you will have row-wise indexing also, and you will have column-wise indexing also. And for both positive and negative indexing is valid in Python. As the dimension of data increases, indexing will work on both directions. So this time, if I have to get this column, first thing is that in the columns index, I have to choose this one because it starts from 0. This thing you have to observe carefully what I'm doing. Maybe if I have to choose second column. So index of second column is 1 right now. If from the second column I have to choose only first value, means only 8, then I may write 0, 1, because in that case 0th row and first column entry only I'll be taking. But what I need right now, I need entire, sorry, this will I'll be writing 0, 1 this way, indexing 0, 1 in that case, not column in between. But this time what I need all these values, means I need all rows. So how do we do that in indexing? Colon, comma, 1. These columns here represent entire row, means entire column. Means all the rows available in first column will be taken up automatically. If I pass a number here, like if I pass 8 here, then it will take 8 rows starting from first one. So 0, 1, 2, 3 up to 7 index it will take. But if I write it colon, comma 1, means first column with all row entries associated to that column will be taken by the system. So what I'll do here is I'll just take up this glucose and I'll write all rows from column 1. As we discussed already, that this is your glucose variable. So all rows from column 1 I'm trying to take, and this represents my column glucose data. We can check it side by side also if you want. That will be also available in the form of array. You cannot identify it very precisely because the values are very large. You can see there are large number of entries because we have almost 761 entries that we have recently seen. This one 761 entries. So these are the values. You can compare them. 148, 85, 183. So this way, 143, 85, 183. In the same way, all the entries are going on. Up to the last variable, you can map it with your Excel file. Last entries are 126 and 93. So it will take all your rows, and last ones we can see here. You can see 126 and 93. Last entry is available in your data. So this way, entire column we could address. So I'm sharing this with all of you. Try this, and then I'll give you task to extract few other columns also. First try this, let me know. Okay, great. So after this, for example, I hope others are also able to do this. Maybe I ask you to get this BMI column. How you will get it? Get this BMI column with all its rows. show me the code, how you can calculate BMI. You just have to grab this single column into your Python platform with BMI variable. Yes. And one thing I observed from the answers that we have received, yes, there is one mistake that I may have done earlier. I have applied here data variable, although this is fine, this is working fine, no issues, because in this column we were not having any missing values, but our recent clean version of variable was clean data. So I'll just put this one here. That is a better way to extract, because uh, previous data was having some missing values, although they were not in glucose column. So that is why it was working fine, no issues with that. But yes, for the remaining columns, because there were many missing values at other places, so we need to be careful what is our updated variable. That only we need to use. So of course, for the BMI calculation, I can write here all rows, and if BMI is in your fifth column, so I'll write it like this, and I can check these values. They appear like this. So we can verify side by side, 33.6, 26.6, that we are able to get here. So in this way, BMI entries also we are able to get. Now I'll show you one more interesting part here. Like if you check your this final variable, this outcome variable, I told you that we have mixture of variables, 0 and 1, both categories we have. First thing, I'll ask you from what we have learned in the theoretical sessions of this course. Listen to my query very carefully. We have discussed this somewhere in our, I think, third day of discussion, the theoretical discussion. I'm asking that if I consider this outcome as my target variable, whether I'll be conducting a regression analysis or a classification analysis. Let us just recall our basics. If I consider outcome as my target variable, whether I'll be conducting a regression analysis or classification analysis in that case. I need more responses. Others also, please let me know what you feel. Any other? So this is going to be a classification analysis. Reason being, there are only two classes, 0 and 1. There are only two classes, although they are already in the form of encoded variable. We discussed this point in that class also. Your classes may be in alphabetical form or may be already encoded into zeros and ones, but we just need to ensure that there are limited number of classes possible from that variable. Like here, only two classes are possible, 0 and 1. So this becomes a classification variable in that case. However, if I take this BMI as my target variable, maybe in certain case study, in that case, tell me whether we'll be doing classification analysis or regression. Yes, very right. So for BMI, we'll be doing regression analysis because this is a completely continuous variable. And you can observe the floating point values also. This is a continuous variable with long range values. So this becomes a regression analysis in that case. Now, that was just a revision from what we have learned in the basics. I'm coming to the point that I'll be implementing further. For instance, just to know your data better, you now need to understand how many patients I have from healthy category and how many patients I have from diabetic category in my data sheet. because that is just a general observation that any researcher may need from their data itself. So we just need to know how many zeros we have in outcome column and how many ones we have, because zeros are representing healthy people and ones are representing your diabetic people. So again, there are several ways to test this. I'll just show you one simple technique. Later on, you can implement different things also, because in Python, there are hundreds of ways to do same thing. So let me just show you. What I'm doing is I'm writing here healthy people and diabetic people that I'll be getting from as a count from my data. np dot sum function I'm deploying, and I'm considering data from -1 column. You can see which column it represents. If I write it like this, which column it represents? Yes, last one, which is your outcome column in the data. So last column I'm addressing with negative indexing, and this indicates all rows of that last column. And I'm writing here equal to 0, means wherever my outcome column is equal to 0, that I'll consider as healthy, and we will just do a sum of all those elements wherever we have 0 entry. All those instances we will sum up, means that count we will add for our healthy patient count. And opposite of this, I'll just take this expression as it is, and I'll pass here 1. Means wherever I have 1 in my outcome column, so that I'll consider as diabetic case. And based on this, I can print my value directly. That includes diabetic patients with value diabetic that we have calculated. And second one, healthy people that we have in our data set. And that comes with healthy variable, for instance. So I'll run this, and this is the count in my data right now. So this is a common practice in healthcare datasets. You will generally not have equal values in both categories if you are working on binary classification. Very rarely in healthcare datasets you will find equal number of observations in both classes. Generally, like when people are visiting any hospital or clinic premises, it is not possible that if 100 people are visiting in a day, 50 will be healthy and 50 will be patients. That is never possible. Generally, majority of people are healthy with some basic symptoms only, but they just go for some quality testing so that they can assure that they are healthy, or if some disease is starting to develop in their body. So majority of people you get from those data sets are healthy, and there are few reported with certain disease. So there is always a imbalance in healthcare datasets. When we work in future courses, like in level 2 course, we'll be discussing that important point in detail, that how we deal with imbalanced datasets while building AI based models, because that is a very important concept when dealing with healthcare datasets, because this is one of the most commonly occurring instance in these type of data points. So try this and let me know if the point is clear for all of you. I'll wait for responses. If we are good up to this, then I'll do some operation on the other data file that I have shared with all of you. That is, yes, this weights and heights data file. So before I show you some operations on this, I'll give you some basic task here, because we have learned that step just recently. The task is that all of you have to try and show me your code in chat box quickly. So first thing is load weights heights.csv file. That is your first task. First, you have to load this file on your Colab platform, and I can say, like, for being more precise, into data variable, for example. You can give any name to your variable, for instance, but I'm giving you just a standard task that you name it as a data variable. Then second task is extract height and weight column from your data. Extraction process also I have shown you recently. So after loading your data file as an array, because you will be using NumPy, you have to extract two columns out of it. Currently, if I show you, observe this task very carefully that I'm giving you. You have to do this and you have to share code quickly with me. So this weights and heights file I'm giving you, it contains three columns right now. I'm asking you to extract height and weight column. These two you have to extract, and then just apply BMI calculation on it. Third step is apply BMI formula on height and weight variables. I'm not asking you to store BMI back to your array. That I'll teach you that how you will do that. But till this point, you just have to do these three tasks, because I believe all of you will be able to do this easily because we have learned this several times by now. I'll wait for your responses. You can give me entire three-step code in one go, or maybe you can share step by step also. That is your choice. We'll take 1-2 minutes for this because this is a very simple thing for all of you now. Try this and share your code. If anyone needs any help, I'll be guiding you further. No worries in that, but first give it a try. I hope all of you are giving it a try. Yes, anyone with the outcome? Do I need to do this? Okay, I can see one response. That's great. One more. Good one. Let us check few of these. I'll run this first one here. Looks fine. If I have to check BMI after this, that's fine. Similarly, we have one more code here. I can run this one as well. Yeah, looks fine. So you people are doing great. We now have BMI values with us and we have extracted it from data variable. I'll make it with comma to be more precise about presence of your data entries. One thing, okay, this is fine if we are working like this. I'll tell you here one more update now. For instance, these BMI values that we have calculated, whatever formula you are applying, like the standard formulas, although when you are having real-time data, you just need to make sure about units also. Like sometimes you have measurements in inches, maybe centimeters or in feet, etc. So accordingly, the formulas will update. That will be your domain specific calculation. Currently we are doing just a basic technique only. We are not considering the units, etc. We are not trying to be more specific with the units. We are just learning the technique only. So if we have the BMI values calculated, and now if I ask you to create a file where you can store them back, like with these three entries, like after calculation you want to store it back somewhere. So what I'll do here is I'm writing here updated data after calculation I'll do, and I'll create one updated data variable in which I'll add NP column stack, and inside this I'll pass weight, height, and BMI, three things. A stack I'm creating basically. So okay, you have given it a variable S also side by side. So I'll write it BMI score underscore values. Exact same variable names I have to use here that you have given. So I'll be updating here. And after this, these values I'll store into a new CSV file, for example, that can contain your specific headers also. So I'll type header first of all, weight, height, and BMI. Three things I need, and then lp.save txt. Inside this, I'll pass weights underscore heights dot underscore bmi.csv. This is my new file I'm creating now. Updated data I have to pass to this file. This is my updated data. I'm just passing it to the newly created file, and the header of which file I have already given as weight, height, and BMI. And similarly, I'll also tell that this is a delimiter file with comma spacing so that it creates a CSV file for me. So delimiter with comma spacing. And then I'll also pass header equal to header. This, we are not skipping header this time because we are writing file. So I'll use header, presence of header at adequate positions. Then I'll make here, for example, FMT if required, not essential. Okay, I can just skip it for now. I'll use the basic version only just to make it easy to grasp for all of you. So I'll write here print BMI calculated and saved successfully, just to get a final indication of what we have created. So I'm just opening this section here so that we can visualize side by side. and I'm running this file quickly. I can see some typo. Let me just check. Okay, there is some issue with the dimension. Let me just re-verify it. We have 3 columns here. Let me put here one more variable. I'll just do a test first. Some x's are not utilized well, it is stating that. And it may be due to data correction is fine. BMI values also are created well. Tag sequence is also going fine here, and weight, height, BMI for header is fine. Updated data, delimiter, header we have updated. Okay, let me just check it once again with maybe some issues with the code sheet itself. Sometime it loses connection from the main file. Let me just refresh everything once again on my Google Colab folder. Since we are already on the verge of session, I'll just take a few seconds to diagnose if it works. But if the variables are lost from Google itself, I'll try to correct them quickly. Okay, this works fine. Just some variable issues we were having somewhere maybe. I just refreshed my Colab file with the new login, and I'll be sharing it again. Although everything was fine, but maybe due to some strange issues, it stopped working behind. So I have just updated my data variables here instantly, although that will not make any further difference. I made it little precise for every step. So exactly same thing that we were doing earlier, the same thing I'm doing here. I'm just using one sample that I already had, where I'm being specific with the units also, because in this current data file we had heights in inches and weight in pounds. So the formula is different, slightly different based on the different units, because mathematical formula will be updated accordingly. But otherwise, there is entire same process that we are using. And based on this, we'll be able to create the CSV file. Like this is a new CSV file I'm creating. And I can show it side by side here. You can see the BMI column is working side by side now. Whatever calculations we have done, that new calculation is working here side by side. So I can share this quickly with all of you. You can try this. Try this on your data as it is, because everything is fine. All the data variables, everything is in the original form. Only due to units, the formula may be different, and rest all things are fine, what I explained earlier. These two variables here are added. This will control, observe this. This last one will control how many digits you need after decimal. That will be updated. And comments we are keeping empty right now, so that we get a clean CSV file in the output. This is just one additional variable we have added, although this is an optional variable, not an issue with that. So otherwise, all the variables is as required. The formulas are updated based on that only. Let me know if you are able to try this. Please let me know what you are trying to ask. Weights, not weights underscore kg. What that means? There may be a chance if this, you can see in my case, this is exactly .csv file. If I download it, you can see, if I download it on my system, there is a download option available. It will be downloaded as a CSV file only. You can see, comma separated file. So if you use it, it will be a directly comma separated file only. We are creating CSV versions only, although we are using array version for operation, but the storing back process is done with the CSV format. I have given .csv extension here. Okay, so we have discussed plenty of things. I have shared one more data file with all of you, although that I have not used right now because we are already on the verge of session. So I suppose we should not take it any further because you all have your precious time further. Just quickly let me know if you want me to include one simple operation on that shared data file also. I can give you one idea about how, with reference to patient IDs, you can calculate some thresholds for variable. Otherwise, I can do that tomorrow also while we will be working on pandas. No issues in that as well. This is because as per your time only, I'll be taking it further. If we want to close now and we can do that tomorrow, then also no problem. You can quickly update me in the chat box. Others also can let me know quickly. I'll just check some majority. Okay, so just one analysis I'll try to do, and in order to save your time, although I can take it from some reference material also, so that you can just see the code directly. Just give me a second, just to save your time. I'll show this with some reference code quickly. It will be just the simplified process, whatever we have done till now, but only one threshold I'll apply on the data file, and you will observe the impact of that quickly on your data, that how it can help you to deal with variables directly with reference to one another. So what I'm doing here is mapping columns for better understanding of your operations in NumPy. And I'm putting a code here that I already have with me. I have tested it on. So first, I'll show you just what this data file contains on which I'm working. The third data file that I have shared with all of you. I'll just open it up. This is containing columns that we have already in diabetes raw data set. From there only, I have taken these columns. But I have added one more patient ID column here because sometimes you need reference with respect to patient IDs. Currently, the patient IDs I'm putting is in the form of numbers only. Starting from 101 onwards, I'm creating patient IDs. Although practically patient ID will have a alphabetical sequence also. So that we will see in tomorrow's session, that how alphabetical data also we can deal with in CSV files. But currently, as NumPy has a limitation of working only on numerical variables, so patient ID for your reference, I have created as a numerical variable only, so that you can just refer to certain thresholds with respect to each other. For instance, if you want to check that which patients have blood pressure above certain threshold, so you can map to their patient IDs directly, maybe in your hypothesis somewhere you want to show a chart or maybe something as a sum up that these number of patients were having higher BP in comparison to my threshold. So you can just get access those patient IDs directly. And for that, I'm using a reference code for all of you. First, observe what we are doing here. With the help of NumPy, this we have already imported, so I can remove this also. The first step, you all know, the same thing we are doing to import data. Now, this is clear to all of you. Then I'm extracting two columns. One is patient IDs column, other is BP column. That is on the fourth position in my data. So accordingly, this one is a BP column. So 0, 1, 2, and 3. So third index I'm targeting here to extract BP. Then I'm putting a threshold of 100, for example, means a threshold of 100 for BP I'm putting here. So what I'm doing, I'm putting a filter where patient IDs with reference to BP greater than threshold I'm extracting. So this will only extract high BP patient IDs. And then I can just quickly print those IDs. And you can see patient 144 has BP higher than 100, patient 185 has BP higher than 100. And we can just verify that quickly here. Like maybe if I go to patient 144, this one, I can verify BP is higher than 100. So instead of manually searching your values, that which ones are above threshold, you can directly apply those formulas here in your code, and it will extract everything relevant from your data itself. So this kind of operations may help you a lot when you are working on your real data files, although this will become much easier further when we do some case studies, etc. in coming days. And also in Pandas, also tomorrow we'll be doing Pandas library. So that is a more friendly library for dealing with CSV data files. I've shared this code in your code share window also. You can give it a try. Let me know if you are good with it. It is just a very simple code, but the usefulness I was trying to tell you for this. I'll wait for responses when you are done with this code. Okay, great. Thanks for the update in the chat box. So we are already ahead of the session timing, and I'll just stop it from my side here. And if we have any queries, any feedbacks, any discussions on the topic, the house is open for all of you. Please let me know. You can put it in the chat box, or maybe if you want to turn on your mic, that is your call. I hope I could deliver you some relevant details in this session as well. Yeah, I can understand this may appear heavy because you are doing coding for the first time, maybe, and we are learning so many things all together in a limited time. But I just wish that this will be useful for you somewhere. And if you do little more practice, like maybe if any of you are working on Excel sheets, you may be knowing several operations that we can do on Excel files. So that also you learned with practice. So if you are good with Excel, that comes out of your regular practice because you know how to apply formulas, how to deal with different variables over there. So in the similar pattern, if you do some continuous practice with Python, you will find this also pretty easier to deal with your variety of data sets. And the capability of Python is that it can deal with all type of data. Excel can deal with your Excel sheets only, but Python gives you freedom to deal with textual data, Excel data, image data, video data, audio data, ECG signals, EEG signals, everything you can integrate on single Python platform. So that gives you a wider scope. That is why we are learning it here, and just assuring that it may be useful somewhere in your domain. So if we don't have any further queries, we can just wind up the session here, and I would love to see you again tomorrow at 6. Thank you very much, everyone.